Good morning to everyone. And today, we are under revision pattern. So, I'd like to discuss something about Method and also check out whether any Method questions will be there in our previous papers. Let us go ahead with the passion. So, look at this. As far as Method is being concerned, fixed and complex. But yeah, so here the method complex algorithm is with us. Let us discuss what exactly the method is and who was invented this method and what is the actual algorithm which is involved in method will be discussed today, and also concentrate on any questions we'll ask you in our previous question papers for our seniors and super seniors, something like that. Okay, however, let us go ahead and let's get started here. So, it was introduced by one of the pioneers of computer science. So, who is Sir John von Neumann. So, Sir John von Neumann, he is the person who introduced divide and conquer for us, and with his approach, what exactly he is trying to explain to us in terms of divide and conquer approach is, so divide the given list of elements or list of records or list of files into exactly two halves, and perform same kind of operation what you did, the same kind of operation on several kinds of list of elements recursively, for achieving the particular output of that particular problem. Okay, so that is the point which he wanted to disclose to us. And here, as far as Medjusat is concerned, it is the perfect, 100% perfect example for divide and conquer approach. It's very efficient when compared to all other algorithms as far as time complexity is being concerned. Whereas in space complexity, Method will be taken very huge amount of space to be performed, so that it could be considered as too worst in terms of space complexity. Okay, in terms of space complexity, it is very weak. It's very weak in terms of storage. But average, best case, and worst case, whatever the case of complexity you could consider, for everything as a sorting algorithm, it has been taken. So it could be taken. So only n log n, only n log n here. So that is the point which we have to consider. And so efficient in terms of running time complexity, but very weak in terms of uses of the storage. Okay, so that is why people are not using this method algorithm nowadays, because huge amount of space is being required to sort the given list of elements or records or files, whatever the input it might be. And it is closely follows the divide and conquer approach, because it was actually divide and conquer approach was defined by Sir John von Neumann, and Method also defined by John von Neumann as well. So that is why whatever the proposed algorithm for divide and conquer will be exactly followed by the Method algorithm. Okay. And what is the problem here in the sense? So Method will be always trying to perform. So do this one here. We would like to take some two different types of elements as input for particular method, and whatever the list of elements, those list of elements will be global value or global variable. Okay, and based on this low and high, would like to divide the given list of elements into so many number of sub problems. So how the sub problem can be divided into many number of sub problems here in the sense. So this is the formula which we have to follow. So a lower of low plus, so high divided by 2, which is taken lower of. Okay, divided by 2, which is taken lower of. For example, let us say this is mid element. For example, it is mid equal to So based on this particular element or based on this particular formula, the given list of elements are going to divide it into as much as such number of subproblems. Then where exactly divide operation will be gets closed here in the sense, as far as divide and conquer. So if this is the condition we have checked in control abstraction of divide and conquer. That is, if small of p small of p, then return p. So we have taken return p. We have taken this one. When exactly the small of p will be gets true here in the sense, divide and conquer approach will be taken this kind of the base condition for recursive calling. So small of p will be terminated, or otherwise the recursive calling of division operation will be get stopped when so the problem P does have only one element with it, only one element with it, single element with it. So if you have single element, yes, your the divide operation will be get stopped. Whereas number of elements more than one element will be there, then the divide operation will be continuously done by method application. And then conquered subproblems will be solved by using the recursion approach, and combine this problem will be combined to original subproblem. Original problem. All subproblems are combined to the original subproblem. So by following sort operation, by following sort operation here. Then what is the actual synthesis? So if number of elements will be n, for example, then n by 2 elements will be taken into consideration on creation of a sublist. Okay, then conquer in the sense this will be recursively solved by using the merge sort operation. I mean, there is a function which we have to define as a merge sort. So this merge sort will be recursively called for number of times, and the combine in the sense two sorted lists, two sorted sublists are being merged together and can be produced as sorted sublist, sorted main list, sorted main list. This is actual synthesis which is being going on in terms of merge sorting technique. And then, so let us consider directly. I'd like to go ahead and take the example from. Okay, let me discuss this one afterwards. We'll solve the example from question paper. It would be better for us. So here n will be equal to 9. So for example, I'd like to specify. So first value will be equal to 1 and last value equal to 9. So therefore, mid value will be equal to the lower of 1 plus 9. So divided by 2. So that would be lower of 5. So therefore, so 1 to 5 will be one sublist, 6 to 9 will be another sublist. In this way, it is going to generate it. Okay. Then here 1 to 5. So let not be write this particular equation for number of times, because you are very well versed about identifying mid for each sublist here. 1 plus 5, that is 6 by 2, that is 3. 1 to 3 will be one sublist, and 4 to 5 is another sublist. 4 to 5 will be another sublist. And then 6 plus 9, that is 15. 15 divided by 2, that is 7. 7.5 actually, of course it is lower up, so that's 7. 6 to 7 is one sublist, and 8 and 9 will be another sublist. Still, small of p is not satisfied, because here small of p will be at this particular place. So the problem p will be having 5 elements. So here the problem p will be having 4 elements. So small of p has not been satisfied. Now here problem p will be having 3 elements, and here the problem p will be having 2, and here also problem p will be having again 2. So here also 2. So small of p is not satisfied. Since small of p will be get satisfied if problem might be having single element. Now let us go ahead to divide this particular first sublist, that is 1 to 3. So 1 plus 3 divided by 2, that is 4 divided by 2. 1 to 2 will be first sublist, and 3 will be single sublist. Okay. Now here it is p will be equal to 1. Small of p will be get satisfied. So here also same procedure. 4 will be single element, and p will be equal to So again, 1 here, here also small of p can be satisfied. P will be equal to 1, small of p will be satisfied. And here also p will be equal to 1 satisfied, here also satisfied, and so on and so forth. All sublists except the first sublist, everything has been satisfied. So division operation is completed for right away from third element to ninth element. But the first and second elements, it is not yet completed. So therefore, we would like to perform one more division operation, something seems like. Now, the division operation will be get start. Get start. If you observe the leaf level, each and every sublist does have only one element. Then, as far as sorting, generalized sorting method. So, if you have only one element with you, it is already in sorted mode. It is already in sorted mode. 10 is already sorted, 7 is sorted, and 25 is sorted, and then 60 already sorted, 90, because everything is individual element. They are not supposed to combine with any other list. So at leaf level, we do have individual elements. So therefore, everything will be so get satisfied the sort operation. Then you will go ahead with the conquer and combine. Conquer and combine will be taken into consideration. Now the small of p. So here, as far as this particular point, divide and conquer technique will be taken. The small of the problem p so has been getting through in terms of 9 elements, that is 10, 7, 25, and so on and so forth to 8. Everything has been satisfied. So the division operation will be get start at this particular point. Now, combine. So what is the purpose of combine here is while combining, it has been taken into consideration two sorted sublists are going to be combined together by applying sort. So look at this, 10 is already sorted order, 10 is already sorted order, 7 is also sorted order. So these two will be combined together on applying sort operation, that is 7 is greater than 10 or 10 is greater than 7. Whatever the operation you could operate, they will be get sorted together. They will be get sorted together. Then 3, these two, if you consider these two elements, I mean 1 and 2 is one sublist and 2 is another sublist. If you take this particular sublist, then you do observe this is the way. 7, 10, and 25, it is in sorted mode. And similarly, at the right side, you can consider the same procedure. The same procedure will be takes place. Okay, in this way, you have to operate the conquer and combine respectively. Okay, in this way, you have to operate the conquer and combine respectively. At each and every stage, each sublist before combining, each sublist is in a sorted order. Try to observe. Each sublist in sorted order. So 2, 5. If you take this particular case, 2, 5 is sorted. If you get this particular case, 3, 8 also be sorted. Then if you take this particular case, yes, 2, 3, 5, 8 is sorted order. So it is also in sorted order. Apply combine on these two for framing of new sublist or new actual sorted list. So look at this 2, 3, 5. So here the elements are in getting sorted. Okay. Apply the same for whatever the application you have. Look at this particular problem. Problem is April, May 2019 set 1. In set 1, you got this particular problem in April, May 2019. So look at this. Discuss the working strategy. Discuss the working strategy of Medisart and illustrate the process of Medisart algorithm for the given data. So the data is this one. 43, 32, 22, 78, 63, and so on and so forth up to 30. Apply the Medisart operation. So what exactly you are trying to perform here is, what exactly your answer will be is, so you need to discuss what is the synthesis of, so you have to explain, let me go ahead to the previous slides. So you have to explain, so this particular problem, you must explain this particular problem. What is this particular problem? You must be explained. What is the synthesis? You must be explained. And what exactly the algorithm? So look at this. This particular algorithm can be written by you. Let me go ahead quickly. So up to this one, you have to explain. So you have to explain this particular algorithm. This algorithm is very important. Of course, merge is not important for us at this particular point. So this is very, very important because here you could have so recursive column of merge sort and merging. So both will be there. So divide and conquer is available within this particular list. So you have to explain this one, and then follow the sort operation. Okay, how the sort operation? Just now I have give you some animation with the same kind of animation you have to follow. Let me go ahead with the paintbrush and solve that particular thing here. Look at this. As far as this particular number of elements 1, 2, 3, 4, 5, 6, 7, 8. So this is actually 1, this is 2, 3, 4, 7, and 8. So therefore n will be equal to 8. So mid value can be equal to, so mid value equal to 4. 1 plus 8 divided by 2, that is 9. 9 divided by 2 is 4.5. Actually, it could be taken floor value. So it could be so. Up to these elements will be first sublist and these elements will be second sublist. So you have to draw in such a way something like this here. Something like this here. So you have to draw in such a way something like this. So obviously these list of elements will be so 43, comma 32, comma 22, comma 78 will be one particular sublist, and second sublist will be 63, comma 57, comma 91, and 30. So these are one more sublists which are available with us. So this will be comes under this area. This will be comes under this particular area, and this will be comes under this particular area. So you need not to write the index values. Need not to write index values. Directly you can take this particular thing here. Okay. Then, so small of p is not satisfied because p will be having here 4 elements. So it is not satisfied. Here also problem is equal to 4 elements, not satisfied. Okay, so therefore again you have to operate list, division operation, divide operation one more time. So if you take a divide operation for this particular sublist, this particular sublist, it could be so 42 comma 32 is the first sublist, and second sublist will be 22 comma 78 is the second sublist as far as the left hand side sublist is being considered here. Okay, in this way you have two sublists. Okay, so like this you have to take into consideration in this way. Afterwards, then at right side you have to consider in such a way 63 comma 57 is one sublist, and 91 followed by 1313 is another sublist you have to take into consideration. Okay, so so these two will be taken like this, and here also taken something like this. So this will be divided into. So here no need to write these n values and mid values also, not required as far as the final examination is concerned. This tree is very important. Writing of this tree is very, very important, and the p values, problem values also very, very important. So problem here it is 2 not satisfied. Problem here it is also 2 not satisfied. Divide operation is not completed. Problem is equal to 2 not satisfied. Here also capital P equal to 2 not satisfied. So that further you have to divide it into so several list of elements. That is 42 is the first list, and the second one is 32. That is 32 is the second sublist. So this sublist is going to divided into, this particular sublist is going to divide it into something like this. And next, 22 is one sublist in the second sublist of elements. Second one is 78. 78 is one more sublist. So let's take into consideration. This is one particular sublist for this one. Here also one more. And here, so 53 is one, and 57 is the second one. So these two will be taken into consideration, so that it could be so taken here, it could be taken here. Then 90 is 91. 91 is the first one. 91 is the first one, and the second sublist will be 13. So these two will be so taken something like this, and here taken something like this. You have to draw the lines. Okay, this is the division. This is the division, and here it is the division, and here it is the division. Yes, everything is gets over. Okay, things are gets over. Now you can observe. So you need to write here p equal to 1 true. So p equal to so 1, which is true. You need to write for 8 elements. So I'm unable to write for all these elements. So please, you have to follow the same kind of a pattern for 8 elements. So arrow mark true. So has been written by you. Okay, continuously has been written by you. Okay. Then at leaf level, the number of elements which are available with the leaf level is 1. So therefore, divide operation is gets completed. The divide operation is gets completed. Now, so here you have to mention one particular line. So divide is stop. Okay, is stop. You have to mention in such a way. Then directly you can draw how this can be gets framed. Directly you can draw. So here on combine operation will be get started here. On combine operation, what exactly could be done? So both elements will be, both sorted list will be merged together. So while merging these two, how you could get here in the sense, so these two elements, so list element this one, and let me take into consideration. This is first one and this is second one. So these two elements are going to be merged together and will be framed. 32 is the first element, which is smaller than 42. 42 will be the second element. Okay. Then 22 will be first element, and the 78 will be second element for the second subject. And then here 57 will be first element, and then 63 will be second element after merging. Then 13 is first element, and 91 will be the second element. So you have to take and you have to draw in such a way. You have to draw in such a way something like this. Okay, you have to draw in such a way something like this. Okay, carefully you have to draw, because drawing of these things are very important. So these two will be combined together something like this. These two will be combined together something like this. These two will be combined together. These two will be combined together. Afterwards, what exactly you are trying to do? So now two sublists are there. This is one sublist. This is one particular sublist. This is second sublist at left hand side. At right hand side, this is one sublist and this is second sublist. These four sublists will be combined and frames two sublists. How these things will be. So make into sublist in the sense. So when merging these two, this sublist and this sublist are going to merging together. Smallest element will be 22. So 32. So 42 is next smallest, and 78 will be next smallest. And here, so 13, 57, what is that? 63 will be next element, and 91 will be the last element. So you have to sort them and show something like this. And you have to sort them and show something like this. These two will be merge something like this. So merge operation will be takes place something like this. This is merging, and here also merging. Finally, how the things will be get occurred here. Two sorted sublists are there here. So the sublists will be seen like this. 13 will be the first one, 22, then 32, then 42, then 57, then 63, then so 78, then so 91. This is the final sublist which we have with us. This is the final sublist which we have with us, and in this way it is going to. Okay, let me let me draw. I'd like to show you each and everything in single window. Okay, let me draw the lines. Okay, look at this. This is the complete one. So in this way you have to draw. So here how you can specify here is, so if you want to specify in a proper way, you could also specify something like this. So that is you need not to write like this also. One more pattern is there. One more pattern which could be able to turn represent divide and conquer something like this. Right away from here to here. So right away from here to here. Let me draw here. It could be divide operation, DI, divide, and from here to here, so it could be conquer and combine. So it's also accepted. While correcting the papers, it's also accepted. Okay, divide operation and conquer and combine operations. It's also be accepted. Okay. So this is the answer for our previous question paper questions. Okay, one of the questions has been asking something like this. This is the answer. Before that, you have to write what is actual problem, what is actual synthesis, and what is merge sort kind of small algorithm which you have to represent it. Then followed by you need to write this one. Then you could get 7 out of 7 marks. Okay, in this way you have to so specify the things here. So let's even go through. For a while, I'd like to show you this one for 1 or 2 minutes. Not exactly 1 minute or 50 seconds, something like that. In this way, you can specify. Okay. So you could also try for this one. In the next question paper, you do have. So they have given for Pixart algorithm, but you can try the same thing on MedSat also. It could also be so helpful to you to get practice for 1 or more times. Okay, so somewhere else you could not find any other kind of thing. So yes, apply Medsar. Look at this. When it is set number 3. Set number 3, April, May 2019. So apply Medsar. Apply Medsar for this particular elements. And draw the tree of recursive calls of Medsar using merge functions. Okay, but using merge and merge sort functions, so both will be gets drawn here. So when things will be given in such a way, you please remember how this could be written here. How this could be written here is, this must be written something like this. Let me go ahead with this paint one more time. So it must be given something like this. So if things will be given something like this. Oh, where could I find the? Okay, let me draw. Let me write in such a way that so f 1 to 10, f 1 to 10, so will be equal to. So they have given something like this: 31, comma 26, comma 28, 28, comma. They have given in such a way: 28, comma 17, 65, 35, 65, comma 35, comma 42, 86, then 25, 45, 25, comma, 45, comma, last one is 52. If things will be given in such a way, if array will be represented and array will be given to you, so how to apply this method? If they will be given something like this here in the sense, you need to take care while writing this particular problem. So you have to draw two different kinds of method trees. Okay, method trees will be written by you for two times. So how this could be written? So let us see. So you can accommodate your page in such a way. You must accommodate the page in such a way, something like this. So here, one is one particular thing is gets mentioned with the array value, that is a of 1 comma 5 will be first sublist. This is first one. A of how many number of elements? 10. So 6 comma 10 will be second one. So comma or colon, whatever the notation they have given. They have given colon, I think. So we have to also mention this. Now here, how you could mention here in the sense, elements must be mentioned. 31 comma 28 comma, so 17 comma, so 65 is first sublist, comma 45 is the so first sublist, and 42, 86, 25, 45, and 52. This is second sublist. So you have to mention in both ways. One is the sizes way, and second one is actual elements way. In both ways, you have to mention. Okay, it could be gets included. Next time you could consider something like this: 1 to 5 in the sense 1 plus 5 6. So yeah, 1 comma 1 colon 3, 1 colon 3 will be the first sublist. So so 4 comma 5 will be second sublist. So here you have to mention 6 comma 10, that is 16. That is 16. 16 in the sense 16 by 2 8. So so 6 colon 8 will be the first sublist, and so 9 colon 10 will be the second sublist. We have to mention in such a way, and the division also must be done in both sides, something like this. Here it is elements, here it is sizes. That is the only difference where we have to got this particular problem, something like this. So list will be mentioned in such a way, you have to draw in such a way. Okay, please remember this. First one is, so of 1 to 10, only elements, I mean sizes will be mentioned for that particular array. Second one is, you have to apply the same, whatever the discussion we have made here, same discussion will be took place here also. Okay, same thing will be taken into consideration here. Okay, in both ways you have to specify, you have to adjust your pace in such a way. Okay, try to write very smaller letters, because in paper it could be very easy to write smaller values. Then you have to do the same operation for twice. One is for sizes and second one is for on actual elements. Okay. That is the only difference. Then, so one moment please, let me take your attendance, then I'll come back to this area. Today, 41 students have attended. వీణా వాణి ఎవరు నంబర్ మార్చలేదు, వీణా వాణి 32, 35, 39 కూడా వచ్చారు ఎవరు. So however, let me come back to this area. So in that way you have to mention. In that way you have to mention the problem which may be asked to you in such a way. Okay, you please remember this, either of these two. So if you left over this particular thing, if you left over to specify only this thing and you are left over this one, you could get some 75% of marks. That's all, not more than 75%. Now, this is the algorithm. Already we have seen this particular algorithm. So here it is, the quicksort Pixart time complexity. So here it might be either in not Pixart, sorry, Metsat time complexity. So either in non-descending order or descending order or random order. Anyway, it could be taken same kind of complexity. Okay. So same kind of complexity. So you please go through the previous, the material one more time because time is very less. So that I'm hurry up to close the class. So please go through the material which I have given here. Okay, out of all these, very important concept is very important thing is this one. So here it is. It is very important. It is very important. As per the hypothesis of divide and conquer strategy, if number of elements that shall be greater than n is greater than 1, then k recursive calls will be so required to divide entire list into number of small pieces by satisfying small of p will be true. So this particular statement is very, very, very important. And of course, remaining everything is same. So we have taken already in quick sorting algorithm. Previously, we have taken we took this particular thing in quick sort algorithm. The same thing. There is no difference at all. The same thing. Okay. The same thing will be gets followed here also. Number of elements equal to 1, therefore T of n equal to just 1. Otherwise, we have to follow this particular thing here. Okay. This is what the revision class for merge sorting. Tomorrow, we'd like to take min-max algorithm. So min-max algorithm also frequently asked question in your final examination. So we'd like to take min-max algorithm by tomorrow. Okay. Day after tomorrow, so string addition. String addition could also be taken by day after tomorrow. Then we have to finish the revision class for unit number 2 by day after tomorrow. Okay.